Once a program gets past a certain size, and it doesn't take long, it's no longer practical to store everything in a single file. You need to break it up into multiple files. This is so fundamental, just about every programming language on the planet has built-in support for referencing one file from another. It's a basic feature. Every language, that is, except JavaScript. So what do you do when your code outgrows your editor? How can you create maintainable, modular front-end code? Hi everyone, my name is James Shore and this is Let's Code Test-Driven JavaScript. I'm here with my lessons learned about front-end modularity. In this episode, we're going to take a thorough look at the options available for modularity in browser-side JavaScript. We'll start with a review of the problem that modules solve, then consider 3 solutions. We'll look at using a global namespace object, the CommonJS modules format, and AMD. I'll close with a comparison of each approach and my recommendations. You can find example source code for each approach at the link on your screen. It doesn't take long for a web app to outgrow a single file. This example here is only 138 lines long, but it's already getting unwieldy. So what we do is we split our apps into multiple files. We usually do that according to the concepts that we have in our existing file. So for example, this file here has 3 concepts. There's a drawing area which handles mapping user input into actual events and drawing stuff on the screen. There's the HTML element class which handles abstractions over the HTML elements such as divs and so forth. And there's the SVG canvas class which handles drawing lines on the screen. So what we're going to do is we're going to take these 3 concepts, we'll put each one in its own file. But now each one is in its own file, and that's a problem. Before, we had it all in a single closure. The drawing area could depend on HTML element and SVG canvas using variables defined in that closure, and they didn't pollute the global namespace. But now that we have these concepts in their own files, how do we get drawing area to refer to HTML element and SVG canvas without putting them in the global namespace? It's not really a problem for this small example, but when you're looking at a large program with lots of variables and lots of functions, global namespace pollution can be a real issue. You don't want to accidentally overwrite one variable or one function with another, and you need to be careful of your vendor libraries as well. So this is where modules come in. Every module system handles 3 basic problems. First, defining files at modules that don't pollute the global namespace. Second, exporting specific functions for other modules to use. And third, importing functions from modules to use in your own. We're going to be looking at 3 different approaches to meeting these needs. The first is the global namespace object. The global namespace object is the simplest and most straightforward of all the modularity options. It works entirely in handwritten JavaScript. The way it works is you create a global object with a unique name. That's your namespace. I'm going to call it example in this case, but you can use whatever you want. A really common convention is to put your namespace in all caps, although I choose not to do that. And then for each module that you have, you create another object within that namespace. So in this case, we'll create an example.drawingArea for our drawing area module. We'll create example.html element for our HTML element module, and we'll create example.svg canvas for our SVG canvas module. By doing this, what we end up with is nested objects. In this example, what we have is the window object, which is our global object, contains our example namespace, which has 3 properties, one for each module. The drawing area module points to a drawing area object. The HTML element property is our HTML element module, and it points to our HTML element constructor. And the same for SVG canvas. The SVG canvas property points to our SVG canvas class constructor. For more information about how classes and constructors and objects work, check out Lessons Learned number 12 or visit objectplayground.com. As I said before, this is an entirely manual process. This is something you can do without any tool support whatsoever, which makes it particularly good for small, simple applications. Let's go ahead and walk through how that works. You're going to define each module independently. Each module lives in its own file. So let's start with drawing area, for example. That is going to act on the global object, which is window in most cases. And the very first thing we need to do is define our namespace. At the top of every module, there will be this line, window.yournamespace equals window.namespace or empty object. What this does is initializes your namespace if it doesn't exist, or uses the existing one if it does. Next, you're going to define your module. So we're going to say window.example.drawingArea equals empty object. That's creating our drawing area module in the example namespace. And then for convenience, we're assigning that to our exports local variable. Next, we export our initialize function. The way we do that is we assign it to our module, which is window.example.drawingArea, or in this case, we just say exports.initialize equals function because we've got that exports convenience variable. And that's it for this module. We could export additional functions if we wanted, but we only have the one in this example. The next module we're going to define is HTML element. Again, we start out by initializing our global namespace. However, in this case, we already have a window.example object, so it doesn't get reinitialized. That's why we have the window.example or empty object. It will use the existing one if it already exists. Then, in this case, we're going to define our module as the class itself. We're going to assign the HTML element constructor to the HTML element property in our namespace. And that's because it's just a little more convenient. This way we can say new window.example HTML element rather than saying new window.example.html element dot something else like .html element again. Now that we've got our class defined, we assign methods to that prototype as usual. SVG Canvas works exactly the same way. We initialize our namespace and then we set up our module. This is a class, so we export it by assigning the constructor directly to the namespace and set up our methods on the prototype as usual. Let's take a look at how this would work if you were using it in your own program. Again, there's three things we care about: defining the module, exporting functions or classes, and importing. To define a module, what you're going to do is create an immediately invoked function expression. That's the IFI. It's function global that you see at the top with the this passed in. Passing in this and then having the global parameter is kind of a fancy way of assigning our global to a variable named global. You don't have to do that. You could use window directly, but I think this is a little more expressive. To export a function, what you're going to do is you're going to define your module as an empty variable, assign that to your module name in the namespace, and then for convenience, assign it to a local variable. And then any functions you want to export, you will assign to your module using the dot notation. That will create them as properties on your object. Similarly, to export a class, if you only have one function to export, which is common when you're exporting a class, what you'll do is you'll create your constructor and assign it directly to your module name in the namespace, and then create methods on it like you normally would with any class. And then finally, to import, you just look in the namespace, the global namespace, for the module you care about. And then once you have that module, you can either construct it or you can reference functions on it, depending on which module you've loaded. Let's look at how that works with drawing area. Here we have our drawing area function in the example. Again, you can find the example source code for this episode at the link on your screen. The way this works is we have our IFI, our immediately invoked function expression. It's taking our global. We're saying to use strict, that is optional. And then we're setting up our global namespace, which is called example, and setting up our exports and our namespace here. So we've created a drawing area module in our namespace. Then we import HTML element from our global, and we import SVG Canvas, and then we export our initialize function, which just ends up going at exports, which is global.example.drawingArea.initialize. Then we also define a private function that is only accessible within our module, and we don't export it, so nobody else can see it. An important thing to note about this approach to modularity is that dependencies are entirely manual. There's no tool here, so you need to make sure that you load the functions you're importing before you load the module that imports them. So for example, drawing area imports HTML element and SVG Canvas. That means that we need to make sure that those are loaded before we load drawing area. You don't have to use multiple script tags as I am here. You can use a tool to concatenate all your scripts together, but if you do, you need to make sure they're loaded in the right order. And that actually makes this particular approach kind of painful, which is why it's best for small programs. Once you get into large programs with lots of modules and lots of dependencies, managing those links between your modules manually becomes a real hassle, and I don't recommend it. Our next approach is CommonJS modules, and this is entirely different than the global namespace object. CommonJS modules requires you to use a tool. I'm using Browserify in the example source code and also in the live channel, but there are other tools available. The way it works is that you run a build step. In your build, you tell Browserify or whatever tool you're using to run, and that will analyze your modules and the dependencies between them and concatenate them all together into a single file with the dependencies sort of automatically hooked together. As a result of this, you can use a really nice and elegant syntax to reference one module from the next. Here's how it works. Defining a module is automatic. In the CommonJS format, every file is a module. So you can put use strict at the top if you want. I generally do, but it's optional. You don't have to do anything special to define your module. Importing modules is also really simple. You just say require and then the file name of the module you want to import without the .js at the end. And exporting functions is just a matter of assigning whatever function you want to export to the exports object. CommonJS will provide an exports and module object to every module. Those aren't globals. They act like globals in that you don't have to define them. They just sort of appear magically. But they're not globals in that they're unique to every single module. So to export a function, you assign it to the exports variable. If you just want to export one function, as is common when you're defining a class, you'll assign it to module.exports. And that means that whenever you require the module, you'll get the class constructor as your result. Let's look at how this works with drawing area. I've got this module wrapped in an IIFE with use strict. That's really not necessary, but it's the way my IDE is set up and the way my linting is set up. So I just use that, but you don't have to. Again, here we're going to require HTML element and assign it to the local variable. Same with SVG canvas. And then we'll export the initialize function by just assigning it to exports. Our handle drag events function we don't export, which means that it's private to this module. Nobody else is going to see it. Really nice and straightforward. Same basic concepts as the global namespace, but a much more elegant syntax. And with all the dependencies handled for you automatically by the tool, you can see how this would work well for a large system in a way that the global namespace approach probably wouldn't. The HTML code for this approach is pretty straightforward, but it does reveal the Achilles heel of the CommonJS module approach. When you run your CommonJS tool, it's going to bundle everything into a single file. Now, you do have the opportunity to do multiple files, but typically you're just going to have one file that you'll then minify. The problem is there's no way to run the code without bundling it all into a file. The CommonJS format with its require, module, and exports variables isn't valid JavaScript on its own, and it won't work without running it through that tool. So you must run your modules through the CommonJS tool, Browserify in my case, or your code simply won't run. As a result, it can be kind of challenging to use the CommonJS modules approach. If you're testing your code manually, if you're running your website in the browser, you need to make sure you run that build step every time you test. But worse, if you get any sort of exception in your code, the stack trace isn't going to have valid line numbers in it. It's going to point to line numbers in the bundled file rather than your original source file. Now, you can work around that using source maps, but it's kind of a hassle. And similarly, when you're using a testing tool like Karma, unless you have special code written to handle CommonJS, what you'll get is line numbers from your test bundle, which won't be very helpful when you're trying to debug test problems. You can actually see us face this problem in chapter 17 of the live channel, where we actually go through and write some code specifically to make CommonJS work well with Karma. That said, you can find tools to make CommonJS work with your tool of choice. For example, here's a link with some code to make CommonJS work with Karma. This is the stuff that we wrote in chapter 17. At the time that I record this, it's still being refined, but you can use it for your own projects. And despite these problems, I do think CommonJS has a lot going for it. It is a much more elegant syntax than the global namespace approach, and it works better for large programs. The last modularity approach I want to share with you is AMD, Asynchronous Module Definition. And this is kind of an interesting one. It's sort of a cross between the global namespace object and CommonJS in that it sort of has the advantages of both, but that flexibility also leads to some problems, as I'll describe in a few minutes. AMD operates in two modes. You can operate in a development mode where everything is loaded sort of at runtime asynchronously. That's where the asynchronous part of asynchronous module definition comes from. What you do is you load the AMD tool in your script tag, and it will dynamically go out and find your JavaScript and bring it down as needed. So you just refer to your modules by the name of the file. So drawing area will import HTML element by just saying, give me HTML element. And similarly for SVG canvas. Now, it's not necessarily a good idea to download your code one file at a time. Due to the nature of the internet, it's often faster to download a single large file than a whole bunch of small files. So AMD has a production mode, which is more like CommonJS. What you do is run a build script, and it will combine all your files into a single file that you can then load, and it will automatically handle all the dependencies, just like CommonJS. The naming is a little bit different. In CommonJS, you would use ./HTML element, and in AMD, you just use HTML element. But other than that, it's very similar. The syntax is actually fairly similar to CommonJS as well. Defining a module is a bit more complicated in that you have to explicitly call a define function, but then everything else is pretty much the same. Importing involves calling a require function, exporting involves setting your functions to exports, exporting a class involves setting your constructor to module.exports. However, this special syntax is not really real. Unlike the CommonJS format, which actually provides a require function to your code, the way AMD works is it parses through your code looking for that require function call, and then it replaces it with a more complex syntax that you can see here in the middle of the screen under step 2b, the script import. And that is the major flaw of AMD. It's got a lot of flexibility to it. There's different ways of defining modules. There's different ways of requiring modules. You can have everything bundled together in a single file, or you can have AMD load files on demand as you request them. You can load CSS. You can load JavaScript. There's a lot going on with AMD. And the result of this is that it's a fairly complicated tool. Now, a lot of people like it. And if you like it, more power to you. However, I do find that the flexibility is maybe not worth the extra complexity and extra debugging time you might end up spending on it. In particular, notice how we have this script import. Although AMD does provide a really nice CommonJS style syntax, that does break down if you're doing anything in your HTML. I'll show you that in a moment. Here's our AMD example with JavaScript. You can see it's very similar to our CommonJS module approach. We have that top level define, but then after that we require HTML element and require SVG canvas, just like we do with CommonJS. Really nice, elegant syntax. And then we export our initialize function in the same way. Handle drag events doesn't get exported, so it remains private to our AMD closure. The HTML, though, is a little bit weird. What we do is we load the require.js script, which is the AMD tool I'm using in this example, and then we tell it that drawing area is our top level module. And then down in our script, rather than using the same type of require we use in our other JavaScript code, we have to use this special alternate syntax where we put in the module name into an array, and then we pass it into a function. And this is what I was talking about when I was saying that there was extra complexity with AMD. However, for a lot of people, that extra complexity is worth it because AMD is also very flexible, gives you a lot of power. Here's a look at these three approaches side by side. We've got the global namespace object on the left, CommonJS modules in the middle, and the AMD approach on the right. Go ahead and pause the video here if you'd like to study these in depth. You might want to switch to full screen mode so you can read the text clearly. Each of these approaches has its own trade-offs. For small, simple programs, I prefer the first approach, the global namespace object. It's really simple and easy. It's vanilla JavaScript, so it works with just about every tool out there. For example, it works with Karma right out of the box. There's no build step, so if you're doing a lot of manual checking of your code, then you just change the JavaScript, refresh your browser, and you're done. That said, it's not really suitable for large programs because of the manual dependency management, and it is kind of a verbose syntax. My second favorite approach is CommonJS modules. It's really easy to understand and it has a very nice syntax. It is the least verbose of all these approaches. It does require a build step though, and as a result, because all your modules are combined together into one giant file, it doesn't produce good stack traces unless you put in extra effort. If you're testing your code manually in a browser, you need to have a browser that will support source maps. And if you're using a tool like Karma, you're either going to need to find or write a translation layer that tells Karma how to understand the CommonJS format. Now you can see an example of that in the screencast with chapter 17. It took us about 2 hours, although that doesn't include research time. Or if you're using Karma, go ahead and look at this issue where I've actually posted a solution to the problem. AMD is my least favorite approach, although I have to say a lot of people like it and some people like it better than CommonJS modules, so it's really your call on that. The advantage of AMD is that there's no build step when you're testing manually, which is a real boon if you don't have the kind of automation that we have in the live channel. It's also very flexible. There's a lot of power to it. However, that flexibility does come at the cost of complexity, and in my experience, that kind of complexity leads to additional time debugging and trying to figure out how to make the tool work for you. So I tend to avoid those sorts of tools. You also will need a build step for production code if you have a large system. And although manual testing works fine, Karma Test will take some special effort, so it's probably true for other testing tools as well. Now, Karma does have out-of-the-box support for AMD, but you have to spend some time enabling it. I didn't do that for the example I built for this episode, and I did notice that although the test appeared to be running, they acted very strange. So you will need to make sure that you actually enable that AMD support if you're using AMD with Karma. So in conclusion, I'd recommend using just the simple global namespace object if you have a small application. If you have a larger application, use either CommonJS modules or AMD. Both have a lot going for them. I personally have a slight preference for CommonJS just because it's a little bit simpler. So that's what I've learned so far about modularity in front-end JavaScript. Thanks for watching, everybody, and I will see you next time.